Hey everyone, it's Kara, an instructor with Juni Learning. And today, we're going to code the game 2048. This project assumes you have some experience with Python fundamentals and the random library. You might have heard of this game before. In this game, the user slides tiles around a box, either left, right, up, or down. Every time the user slides the tiles in a direction such that at least one tile moves, a new tile is added to the board. Every tile has a value on it. The smallest value possible is a 2. If two tiles with the same value are slid into each other, they combine into one tile that has double the previous tile's value. If there are 3 of the same tiles in a row, the 2 farthest in the direction of motion will combine and the third will stay the same. If there are 4 of the same tile in a row, they will combine in 2 pairs. The user loses the game when the board is full and there are no more possible moves. The user wins the game when there's the value 2048 on the board. To code this game, we're going to complete the following steps. Step 1. We have to set up the board using a list of lists. We'll want to create a temporary board for us to practice some of our functions on. We can use zeros in our list to represent blank spaces, and the value to represent valued tiles. We also need to create a display function, which will print the current board in an orderly format. After doing this to set up the board, for step 2, we need to create functions that will merge values left, right, up, and down. We probably will have to create functions to reverse and transpose the list of lists to help us do this. At this point, it'll be time to actually work on the game. So for step 3, we will set up the start of the game by creating an empty game board filled with 2 random tiles with values 2 or 4. For step 4, we can expand on the game and set up rounds, where the user will have the option to merge in different directions and the new board will display. We can also set up code that will test if a move was successful or not. Then, for step 5, we can set up adding a new value to the board each time they make a successful move. Finally, step 6 is to set up functions to check if the player has won or lost. Let's get started. Again, we're going to actually make the board with a list of lists. There will be a list to represent each row of the board, and these lists will be stored in another list. So I'll be able to test the code I add. I'm going to create an already filled board. We can do this by writing board equals square bracket 0022, comma 2220, comma 4004, comma 0200. This code represents a board filled with 2 2s next to each other in the first row, 3 in the second row, 2 4s in the third row, and 1 2 in the final row. The first thing we have to do is create a display function, so we can print this board out in a way that looks like the classic 2048 game. Inside this function, the first thing we'll want to do is set up a loop that looks at every row in the board by writing for row in board. Then, we can think about how we want this board to print. I want there to be vertical lines between each value. So I'm going to create a variable called cur_row, short for current row, which will be what we eventually print, and start it with the value of 1 vertical line in quotes. Then, we need to look at every element in the row by writing for element in row. Now, we need to check what these elements are. If the element is a 0, we want to add a space onto whatever cur_row was before, using the plus equals. Then, we need another vertical line. If the element is not a 0, that means we have an actual value. So we want to add the string version of the element and a vertical line. Outside the loop, we'll need to print cur_row. And then outside of both loops, we should add an empty print statement to print an extra line. Now, if we call or use the function, we can see that our board prints in a nice, readable format. There's actually one problem though. What if I change one of the values in my board to 16? Now, when we display it, it looks kinda weird. We actually need the board to print more spaces depending on how long the values in the lists are. I'm gonna add some code to identify the largest value currently on the board. It will look at all the values using some nested for loops, and each time check if the value we are looking at is greater than the current biggest value. If it is, it will make that value the new largest. Then, we can create a variable called num spaces, which we can set to be equal to the length of the largest number. We just have to use the str function because len does not work on integers. Now, this variable holds the number of spaces we need in an empty cell to accommodate the largest value. So, we can change the line where we add one space to cur row and make it so that it adds the correct number of spaces by multiplying the space by num spaces. When we multiply a string by a number, it creates a new string with the number amount of copies of the old string. So for example, if we take one space and multiply it by 3, our new string will be 3 spaces. We also need to change the line where we add an actual value to the board. This is actually a bit trickier because if, for example, there's a 3-digit number on the board, all the 1-digit numbers need 2 spaces before them, but the 2-digit numbers only need 1. We can do this by adding a space multiplied by num spaces minus the length of the element we're currently looking at, again using str. Now, if we test this, no matter how big the values on the board are, the board displays correctly. Now, we're on to step 2, creating the merging functions. Before I do this, I'm going to create a variable called board size and set it equal to 4. We won't really change this during our program, but it would allow us to easily change the size of the board if we wanted to later. I'm going to focus on merging one row left first. I'll create a function to do this called merge one row L that takes a row as an input. First, we need to move every element in the row as far left as possible. To start, we need a for loop that looks at all the values from right to left. We can do this by writing a for loop with the range board size -1, (0, (-1). Then, we need to test if there's an empty space to the left of the value we're looking at by checking if row I-1 equals 0. If there is, we need to make that space whatever the value we are looking at is, and make the current spot that we are on empty. To actually move everything all the way to the left, we have to repeat this process for 1 time less than the board size. In the case of the normal game, with a 4x4 board, it will happen 3 times. Then, we can worry about actually merging the values. We have to look at every value in the row, except the last one, by repeating in the range board size -1. Then, we test if the element we are currently looking at is the same as the one next to it. And if it is, we need to merge them by saving double the original value in one spot and setting the other spot to 0. Finally, we have to move everything to the left one more time and return the row. Now that we have this function, creating a function that merges the whole board left will be easy. I'm going to give all of my merge functions inputs of the current board, so we can use them in more ways later. But inside this function, all we have to do is use the merge one row L function on each row and save the row it returns in its place. Then we can return the new state of current board. Now we can test this by calling merge left board, then displaying it, and we see it successfully merges the board left. But what about all the other directions? Rather than writing a bunch of functions to merge in each direction, I'm going to write a reverse and a transpose function. The reverse function will reverse the order of each row. It will take a row as an input, then add all the elements from that row to a new list in reverse order. Then it will return the new list. I'm actually ready to write my merge right function. To merge everything in the board right, we can look at every row in the board, reverse it, merge it to the left, and reverse it back. Now, if we want to test our merge right function, we can see that it works as well. The transpose function will flip our board across the diagonal. So, for example, an element in the first row, second column, would go to the second row, first column. In my transpose function, I'm going to look at every row in the board, then look at all the elements in that row that are above the diagonal by repeating in range j, board size. Then, if an element isn't on the diagonal, I'm going to swap it with its corresponding element below the diagonal. When swapping, you almost always have to create a temporary variable to hold one of the values until you can put it where it's supposed to go. Then, we need to return the transposed board. Now, to merge up, we just transpose the board, merge left, then transpose back, and return the new board. When we test it, we can see that it works, and we can create a merge down function by transposing, merging right, then transposing again. This one works as well. Now that we have these functions set up, we can delete our temporary board that we've been practicing on and work on code that will actually run the game. This code will go below our function definitions to keep everything organized. It's common convention that function definitions go at the top of your code. I'm going to define one new function first. This will generate either a 2 or a 4 to add to the board. I'll just call it pick new value. I'm going to make it so that 1 in 8 times a 4 gets chosen, and any other time a 2 gets chosen. I'll need to import the random library into our code in order to accomplish this. Then use the random.randint function. Now, back in my main code, I'm going to create an empty board by filling lists with zeros and adding those lists to my main list. Next, I need to add 2 values to a random location on the board. I'm going to make a variable called num_needed and set it equal to 2 because I still need 2 numbers to be added to my board. Now, I'm going to repeat while num_needed is greater than 0. And I'm going to pick a random row and column. Then, if the spot at the random row and column I picked is empty, I'll add a new value to that spot and decrease the amount of numbers I need. This will guarantee that we get 2 values added to different spots. Now, I'm going to add a print statement explaining the game and its rules, then display the starting board. Before I set up the rest of the game, I need to create a variable to help determine when the game is over. I'll name it Game Over and set it equal to false, since the game just started, so it's not over yet. Now, we can repeat while not game over, using a while loop to repeat the different rounds of the game. The first thing we have to do every round is ask the user which way they want to merge, using an input statement. I'll save the answer in a variable called move. I also am going to assume the best and assume they entered a valid input. So I'll create a variable named valid input and set it equal to true. Now, we need to figure out which way the user wants to move, and then move in that direction. In my print statement, I told the user that we would be using WASD to indicate up, down, left, and right. So we know that if move is equal to D, they want to merge down. We need to update the board so that it has been merged down, in this case. I'm now going to add some elif statements, testing the other directions and executing the correct function. In an else statement, we can set valid input to false, because if they typed anything besides the values we tested for, their input is invalid. We can add an if statement, testing if they didn't enter a valid input, and printing a message asking them to try again if so. Anything else we might want to happen will only happen if they entered a valid input, so we can put it in an else statement. We need to make sure that the first thing in this else statement is the display function, so we display the new board. We can test this and see it works how we would expect. Next, we need a way to test if their move was successful, because if nothing actually moved, they should get to try moving again in a different direction. We can actually test this by creating a copy of the board before we complete the move. Because if the move was not successful, the board would look exactly the same as it did before. I'm going to import the copy library and set tempBoard equal to copy.deepCopyBoard. Now, tempBoard will be an exact copy of board. Now, inside the else statement, but before we display, I can test if the board is equal to tempBoard. And if it is, I can tell them to try a different direction. I'm also going to put the display function in an else, because we only need to display if something's changed since the last move. Don't worry about checking if the player has lost just yet. We're going to add that code somewhere else. Now we know any code inside the else of this if statement will only happen if the move the person made actually changed something. That's why we need our display function to be inside of it. If something has changed, that means there has to be at least one empty space on the board. So we need to define a function that will add a value to the board. This function will be pretty similar to how we set up the board initially. It will pick a random place on the board to try to add a value to. The difference is, in this function, the computer has to keep picking random values for the row and the column until it finds the values for a spot that's empty. We can do this using a while loop. Then, we can set the empty location we found to a new value using the pickNewValue function. In our main code, we can call this before we display the board so that we can see where the new value pops up. Cool, right? Now it's time to add the code testing if a person has won or lost. I'll write functions to test these two situations. Our function testing if the person has won will be really easy. We just need to set up some nested loops and test every value on the board to see if it's equal to 2048. If it is, we return true because the user won. Otherwise, we return false because they haven't. We actually want to add this function before we add a new value. We can say if won, then display the board, print out a message saying the user won, and then set game over to true because the game has ended. We can put the rest of our code in an else statement because it only needs to happen if the player hasn't won yet. Testing if the player has lost is a bit more difficult. I'm going to create a new function called noMoves, testing if there are no moves left. Inside of noMoves, I'm going to create two temporary boards, again using the deep copy function. I'm going to call them tempBoard1 and tempBoard2. Now, I'm going to merge tempBoard1 in every possible direction. And every time after I merge, I'm going to test if it's still equal to tempBoard2 before merging in the next direction. If temp board 1 and temp board 2 are still equal after all merges, then there are no moves left, so I'll return true. Otherwise, I can return false. Now, after I display the board, I can test if there are no moves. If there aren't, I'll print a message to the user and set game over to true. Now, if we test it, this game works exactly like the app. It just looks a bit different and we control it in a slightly different way. Try to get to 2048, but beware, it's pretty challenging. Good luck building your own version of this game.